Hi, welcome back. In the previous lesson, we understood the difference in research designs between one sample test, two sample test, and more than two sample test. So, in this lesson, that we are going to understand how we can develop null hypothesis and alternative hypothesis for two sample test, and also we are going to use a case for difference of means, two population means when population standard deviations are known. Okay. So this is that as we are discussing that in case of two sample test we will have two different population mean and two different that sample means will be there. Okay. So especially null hypothesis can be framed like this when we have two sample test we are going to use when we use two sample test. Okay. This null hypothesis can be the difference of two population means mu1 and mu2 minus mu2 can be greater than equal to, can be less than equal to, or can be also equal to. Okay, this is called difference. Okay, and in reverse is true in case of alternative hypothesis, that is called H1. So mu1 minus mu2 can be less than or greater than or not equal to. So this is called difference, that what we say. Okay. So here is one example that here is a case that we are going to use. Let us understand the uh, basis. Okay. So two sample test difference in two population means when population standard deviations are known. That means we will be given the difference in two population means, and we will be also given this like standard, will be given also this population standard deviations will be given. Okay, let us understand this. These are the following assumptions we must see. So sample size, say when we have two samples we will have two sample size n1 and n2. Okay, two sample size. So therefore n1 and n2 of both the samples drawn from two populations are large. Minimum it has to be 30. Let us remember this. This has to be minimum 30. And the corresponding standard deviations like sigma 1 and sigma 2 are also known. That means these will be given. The samples are drawn from two normally distributed population. That means the population distributions has to be normal. This is the main parameter of parametric test. Population distribution has to be normal. Okay. So let us understand this case. There is a college. The name of the college is SIME. Okay, the dean of SIME College believes that the graduating students with specialization in marketing earns at least more than 5,000 more per month than the students with specialization in operation management. So this is the contention that the dean believes that marketing specialization earns 5,000 more salary than the student of operation specialization. What is the claim? So this is the claim. The claim is 5,000 more. Okay. So therefore we when we build, because this is important to understand, because when we are going to build or develop H0 and H1 we have to check this, because the claim is it is more than, at least means it is more than 5,000. Okay. So to believe his to verify his belief, the dean collected a sample data from his graduating students as shown in the table. Okay. So conduct an appropriate hypothesis testing with alpha value of this is the level of significance 5% or 0.05%, whether the difference in monthly salary is at 5,000 more for students with marketing specialization compared to operations specializations. Assume that the salary of students in both the specialization follow a normal distribution. This is the requirement for, because data, that is population, that is data distribution has to be normal. So this is given. So this is the data that we have been given. This is the sample size. N1 is 120. This is N2 is 45. This is the mean salary, estimated mean salary. Okay, of this is for marketing specialization. This is this is for operation specialization, this is the population standard deviation, these are known. Okay. What is given? So we have been given the difference between two population mean, that is called mu1 and mu2. What we call the difference? We have been given this difference is 5000. Okay. Then n1 we have got, this is 120. Then n20, n2 we have got 45. Then we have got sample, okay, mean. Okay, we have got sample mean as this 67,500. This is also we have got 58,905. So we have also got sigma. This is the population standard deviation, is denoted by the symbol that is called sigma. Sigma 1 7,200, and this is 4,600. We have got. Okay. So the null hypothesis can be framed like this, like this null hypothesis can be mu1 minus mu2 is equal to or less than. The claim is, let us see, this is the claim. Claim is at least, means claim is more than 5000. Therefore, null hypothesis, this is the existing theory, because the claim is questioning the theory, as we have discussed in the earlier lessons. So therefore, the null hypothesis is against the claim. It is less than or equal to 5000. So in case of alternative hypothesis, so this is mu1 minus mu2 is greater than 5000. Got it? That means it's a right tail test. So what is, so because direction of the test, you can see this is at the right side. It's a right tail test. So this is the Z formula for calculating the Z statistics or test statistics. So we have got x bar 1, then minus x bar 2 minus mu 1 minus mu 2. This is sigma 1 square by n1 plus sigma 2 square by n2. Okay. So in case of one sample test, if you have remembered, the formula was like this, like it was x minus mu divided by sigma by root n. So exactly like that, since we have two sample tests, this is the two sample test, we have two x bar and two mu's and two sigma and two n. Accordingly, these have been that placed like this. Okay. So this is the what we have done here. We have here put the value here. X bar, this is x bar is 67500, x2 bar is 52950 minus 5000, that is mu1 minus mu2, this is given. Okay, 5000 divided by, this is the sigma 1 square, sigma 1 square, this is 7200 square divided by 120, this is 4600 square divided by 45 equal to Z value. We have got this. Okay, this is the Z calculated or test statistics, what we can see. So then what is the next step? The next step that we have to find the critical value, Z critical. What is the Z critical value? Z critical value for 5% level of significance is 1.645. Okay, let us see, 1.645. So this is the Z critical. This is the Z critical. Z critical is 1.645. You can see this is 1.645, and this is the Z statistics 3.73. This is the 3.73. This is okay, 73. That means it clearly falls in the rejection area. Therefore, what is the conclusions? Since Z statistics in the right tail test, Z statistics, that is within bracket 3.73 is greater than the Z critical within bracket 1.645, and it falls in the rejection region. Therefore, we reject the null hypothesis. Okay. Therefore, we reject the null hypothesis. What is the null hypothesis? Null hypothesis means, so this is the null hypothesis. Okay. That means there is no significant difference, okay, between the salary of both the specialization students. Okay. So that's for the lessons. We'll discuss two more cases in the subsequent lessons. Thank you.